Hey guys, what's up? So today we're going to be looking at areas and perimeters of simple plane figures. Okay, so we're looking at the area and we're looking at the perimeter of plane figures. Okay, and it says a plane is defined as a flat, smooth surface with no thickness. Example, this computer screen, right, is flat and smooth with no thickness, or the surface of a whiteboard. Okay, and a plane figure is a shape. It's a shape that can be drawn with all its points in the same plane. So in this case, it's really the two-dimensional plane that they're speaking of, guys, right? Two-dimensional plane. Okay. All right. So an example is circles, polygons such as triangles, squares, rectangles, and so on. So we're going to be looking at a lot of polygons, guys. A whole lot. Rhombus, the trapezium, all types. All right, guys. So we're going to be looking at a lot of different shapes, okay? Circles and many other polygons such as triangles, squares, rectangles, and so on, okay? And so we have some definitions here. It says the area is the size of the surface of the plane figure, and the perimeter is the total distance around a two-dimensional shape, okay? So basically, we're going to use this square. I'm going to use this square below as an example, right? And the area would be the shaded figure here, which is the total area for the square, meaning how much it actually takes up in the two-dimensional plane. And the perimeter is the distance around it, right? So it would be the distance of here, 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 and here, okay? So let's just play with this and find the perimeter. So the perimeter P of this square would be 3 plus 3 plus 3 plus 3, right? 3 meters plus 3 meters plus 3 meters plus 3 meters, which would actually be equal to 12 meters, right? And the area of a square is actually equal to its length multiplied by its length, right? So this would be 3 meters multiplied by 3 meters, which would give us 9 meters squared, okay? So you notice area is in meters squared, right? And perimeter is still in just regular meters because we didn't multiply it by itself. And it's very important to know that area is usually in meters squared or centimeters squared. We did that earlier, but guys, don't forget to put the squared on the area. All right, guys? Okay, so the first one we're actually going to look at, guys, the first figure we're going to look at is triangles, okay? Because I think triangles are just so easy. They're really easy, they're fun, they're nice to understand, and many of us may remember triangles from prep school or primary school days. So let's just get into triangles to find the area of a triangle and to find the perimeter of a triangle, okay? Awesome, guys. So now we're going to be looking at triangles in detail. So it says here the triangle, right? We're going to be looking at a triangle, and this is an example of an acute angle triangle, right? Because all of the angles in the triangle are less than 90 degrees, okay? All right. So in this triangle now, we can see that we have the perpendicular height, right? And we know it's perpendicular because of this little symbol here. This actually means 90 degrees, right? And we have the base, which is B, right? The base of the triangle. And we have A, which is the length of this side, and C, which is the length of that side. Now the area of this triangle is equal to half base times height. I'm sure you've heard it before. It's very common. You really can't forget this, guys. It's just half base times height. The perimeter is the distance of the outline of the triangle, right? So all that would be is A, B, and C, right? So the perimeter is the distance A, B, and C, okay? So B here is the base of the triangle, as I said earlier, and H is the perpendicular height. The height must be at a 90-degree angle to the base, okay? Cool. All right. So if we actually find B as a subject for the formula here, we can see that the base B is equal to 2 times the area over h, right? There may be cases where sometimes you're given the area and the height and they ask you to find the base. And also, if we find h as a subject of the formula here, the height is also equal to 2 times the area over the base. So there are times when they will give you just the base and the area and ask you to find the height, okay? And it says we will be handling 3 types of triangles regularly. One is the acute triangle, which is the one we did here. The next is the obtuse triangle, which is this one here, where this angle is greater than 90 degrees. Okay, so this angle is probably about 110 degrees. So it's an obtuse triangle. And we'll be handling the right angle triangle, where this side here is actually a right angle to the other sides. Okay, so these are the three types of triangles we'll be going through, and you're gonna get used to them, guys. You're really gonna get used to them. We really are going to do these over and over and very often. So what we're gonna do now is we're gonna look at some examples where we're gonna find the area and the perimeter of these regular triangles, of these acute triangles, obtuse triangles, and right angle triangles. Also, for the obtuse triangle, many of the times you'll be given a dotted line right here, and this dotted line would represent the height, right? And they would put a perpendicular sign here, and you would get the height. So even though this side is equal to 9 meters, the height may be 8 meters. Okay, so many times in the questions, guys, they actually don't even give you this 9 meters. They just give you the perpendicular height, and you have the base already, and you're supposed to just find the area using the base and the height. But sometimes they give you the 3 sides and ask you to find the area, but we eventually are going to go into that. So let's do some examples now. All right, guys, so I left the formula for a triangle over here and the perimeter, okay? And we have 3 examples here, 1, 2, and 3, right? 1, 2, and 3. And it says find the area and perimeter of 1, 2, and 3, okay? So we're gonna do these 3 examples, and the first one, we can see that this is actually a right angled triangle, okay? So the first example we're looking at is a right angled triangle, okay? And to find the area, let's find the area first. It would equal to half base multiplied by height. And the height in this case is 3 meters, okay? And the base is 6 meters. This is the easiest one, guys, because you can clearly see the height and you can clearly see the base. Right, so this is a half multiplied by 6 meters, which is the base, right? Multiplied by 3 meters, which is the height. So this should be equal to, this 2 can go into the 6 3 times, and you would end up with 9 meters squared, okay? So the answer for number 1, the area, is equal to 9 meters squared. Now the perimeter, P, would be equal to A, B, and C, meaning the distance of all the 3 sides of the triangle. So 3 meters plus 9 meters plus 6 meters would be equal to the perimeter for number 1. And that would end up being 12. 3 plus 9 gives us 12, plus 6, which would give us 18 meters. Okay, so that's the answer for number 1. All right, guys. So let's just clear this and write this up there. Okay, so the area is 9 meters squared, and the perimeter is equal to 18 meters. Okay, notice that the area is in meters squared and the perimeter is still in meters, not meters squared. Okay, all right, so let's look at number 2 now. Okay, so number 2 is an obtuse. This is an obtuse triangle. Okay, and we can see here that this angle is clearly bigger than 90 degrees. Okay, that's why it's an obtuse triangle. And in this case, we need to find the area for number 2. So the area would be equal to the same formula, half base times height, right? So half base times height would give us a half multiplied by the base, which is 5 meters, multiplied by the height, which is 9 meters. Cool. And notice the height is this here based on the perpendicular height. And this is actually 10 meters for the side here. So we're not going to use that side because it's not a right angle triangle, but we need to use the height. Cool. So 5 times 9 actually gives us 45. And if we divide 45 by 2, we should actually get 22.5 meters squared. Okay, so that's what we should get for the area. Now the perimeter for number 2 should be equal to the 5 meters plus 10 meters here plus 13 meters. So it would be 5m plus 10m plus 13. Oops, not 113. 13 plus 13 meters, which would be equal to P would be equal to 13 plus 10 gives us 23, and 23 plus 5 gives us 28 meters. All right, cool. So that was pretty easy, right? And let's just clear this. All right, so the area is equal to 22.5 meters squared, and the perimeter is equal to 28 meters. Cool. All right, so for the last one here, this is a normal acute triangle because all the angles here are less than 90 degrees. Cool. And we can see here that the height, the perpendicular height, is equal to 4 meters, and the base is equal to 6 meters. All right. So for number 3, to calculate the area, it would be equal to a half base times height, which would be equal to a half of the base, which is 6, times the height, which is 4, right? And 2 can go into 6 3 times, so we should actually get 12 meters squared as the area. And the perimeter, let's write that over here. The perimeter should be equal to 6 meters plus 6 plus 6 meters, right? And we should actually end up with 18 meters for the perimeter. Cool. So let's just clean that up and write that neatly. All right, so the area is equal to 12 meters squared for number 3, and the perimeter is equal to 18 meters. Okay, the perimeter is equal to 18 meters. Cool. All right, so we finished these 3 types of questions, guys, and we're going to go into another situation like the last situation with triangles. And eventually we're going to do more advanced triangles later towards the end of the syllabus. But these are pretty much all the triangles you're gonna get, guys. You're gonna get the acute over here. This one is acute. Let me just write acute here. You're gonna get the acute type of triangle. Okay, you're gonna get the obtuse, and you're going to get the right angle triangle. Okay. So we're going to look at another situation for triangles, okay? A specific situation where we can find the area without using this formula. It's a different formula, okay, guys? All right, guys, so that's it. And I'll see you in the next lecture. And remember to do your best, and God will do the rest.